Hey, Math Moment Makers, it's Kyle here, and today I'm really excited to talk about something that I think we've all experienced at some point in our teaching career or maybe as students, and that's this idea of using cross multiplication when solving proportions or proportional relationship problems or just working with ratios and rates in general. In this video, we're going to share a problem-based lesson that will help you sort of break away from rushing to the algorithm. In this case, the algorithm being cross multiplying as a means to solve for an unknown in a proportion or in a ratio or rate style problem. So let's not waste any time, and here we go. Let's dive right in. That's right. We are going to be diving into this idea of solving proportions, but without setting up and solving proportions. You'll actually probably know if you read through the Common Core or many newer curriculum across, at least here in North America, I know here in Ontario, we don't really explicitly talk about setting up and solving a proportion. So the question then becomes, what do we do instead? Or is it just implied that we're doing this work even though the curriculum doesn't necessarily specifically talk about it? Well, actually, there's some things that we can do to develop proportional reasoning skills that will help students not only be better doers of mathematics when they come to ratios and rates and proportional relationships, but also the idea that they will also be able to essentially sharpen their numeracy skills, their flexibility with numbers, in particular, their multiplicative reasoning skills. So, for those who feel like students don't know their math facts, like their times tables or simple division problems, this is a means in which we can actually help them to build fluency and automaticity in that area as well. But we tend to not get that benefit if all we're doing is trying to pluck numbers out of a problem and setting up and solving proportions with something like cross multiplication or any of these other sort of named protocols or procedures for solving these problems. So today we're going to dive in, and we're going to begin by jumping over to the Make Math Moments website. And in particular, we are in the problem-based tasks and units section. And for those who haven't been there recently, you'll notice that we have a bit of a makeover here. And really what we've done is we've got 4 tabs here that give you sort of a little bit of flexibility in how you find the tasks that you're looking for in your or for your classroom. So we can start with the concept continuum. We can look for sort of big ideas and sort of see how they develop. So for example, if I'm looking for a number and operations, fractions, decimals, percentages, we've got all kinds of problem-based units that we could be exploring here. But today what we're actually going to do, I'm going to use the Common Core tab. And I'm going to jump straight to grade 6 is sort of where ratios and rates and this idea of proportional relationships really starts to explode. And unfortunately, a lot of students don't really walk away with a solid understanding of those ideas. So I could jump to a specific standard, or I could just go ahead and click grade 6 and we'll just hop straight down to grade 6. I can even, look at specific expectations that match these different expectations here, and they will pop up on the screen as you see fit or as they apply. But in this particular case, what we're going to be doing is I just want to give you sort of a view of how much work for grade 6 we have here in terms of problem-based units, where it could be really helpful, dividing fractions, multiplying fractions, all of this work that's really important. But we also have a particular task which will be turned into a unit. Right now it's a single task, but it's going to be turned into a unit. It's called stacking paper. And really, when we head over to this particular task, you we'll eventually see multiple days up at the top, but right now we just have the single day. And some of you might recognize this from my website or my old website, tapintoteenminds.com. But this is a made over sort of version of the task where really trying to get at some big ideas with students. So we start off with a notice and wonder, as I often do, where we get students watching this short video clip and they see the packages of paper, they see the height of the wall. They're not exactly sure what we're going to be doing next. We get them to share, I see a chair, I see shelves, I see all kinds of things going on here. I see a clock on the wall. Some students say it's 12 o'clock, some say it's 9 o'clock or quarter to 12, or some are saying 9, depending on the hands. And you get all kinds of things shared out here. And really what we want to start with, after we share all the noticing and wondering, we ask students about how many packs of paper do they think it'll take to reach the ceiling. That's sort of that's where we start. That's our estimate. That's where students start sharing their thinking, sharing their approximations based on essentially some spatial reasoning here. Some students might, zoom in and actually notice that, hey, wait a second, like I might be able to, is that like 5 packs per brick here for a row of bricks, or is it like about 4 packs, or can I use that as a means to help me determine the height of the room in packs, and then maybe I can use that for my estimate. So all kinds of great thinking that can be done here before students share those estimates and before we head into the real purpose of this task, where we give them the height of the room in centimeters. Of course, you could modify this if you're in the United States and you don't want to use what would be a non-standard measurement for you. Of course, you could change this to to inches or feet or whatever you choose. It's really flexible. But here it works really well because we've intentionally picked values that work. That are reasonable as well. So it's not exactly 25 centimeters for this for 5 packs of paper or reams of paper, or exactly 275 centimeters, but it's close enough where we could work with it. And then we can also say, you know what, we're not going to do anything with our calculator here. I want you to convince us how you know, and you can't just say, here's the number of packages. You can't just say 40 packages or 70 packages or whatever. You actually have to convince us. And the goal here, when you head over to the guide tab, is to really elicit some thinking around proportional reasoning and proportional relationships. In particular, this idea that we can actually scale in tandem. What we actually have here is we have a composed unit ratio where we're comparing the height of the packs, or the height of the ceiling, really just height in general. And we're comparing the number of packages. So it's really the relationship between the height of the packages and the number of packages. And this composed unit ratio allows us to sort of think of it as one unit that works together, even though there's 2 quantities in ratio here, that they work together and we can actually scale them in tandem. So as more packages emerge, more height emerges, and it happens in a very consistent way. The constant of proportionality sort of glues these 2 quantities together, and they move together well in tandem. So rather than us going back and, let's say, grabbing this work here and saying, okay, well, really what we have is we have this composed unit ratio where it's basically 25 centimeters to 5 packages, which is equivalent to the ratio 275 centimeters to X packages. That would be essentially how we might traditionally teach this or instruct students to solve this problem. But really here, what we're trying to do through this context is we're actually trying to emerge the opportunity for them to scale in tandem in a multiplicative way without necessarily jumping to a proportion. Okay, the idea of a proportion may emerge. However, here we really want students to use mathematical models and strategies in order to emerge this idea. So in our teacher's guide here, we talk about how we facilitate this lesson to get them to the point of the struggle prompt where we ask them, the number of packages given the height of the room and the height of the 5 packages. But then we essentially want to give students the opportunity to productively struggle. All right. And you'll notice here that, we have some student approaches that we share, one of which might actually be drawing out the idea or drawing out, sort of the height of this room and sort of scaling your way there. And you'll notice that this particular student actually uses a additive and actually, I think it's just an additive strategy here, which is not exactly where we want to be when we're working with ratios and rates. We actually want to be thinking multiplicatively. But if you have students in your class that are accessing this through additive thinking, that tells you right away that, wow, if I was to jump to trying to set up and solve a proportion, that's not going to help this particular student with where they are in their thinking journey. And I have some of this work here. If I flip over to my document camera here, I'm going to go just straight to the document camera. You'll see that I actually have some of this work here because I actually crafted it for this particular task based on what I've seen in the classroom from student work. So, you'll see here in particular with this particular student's work, you'll notice that, we have our packs and our height, and you can almost visualize the packs of paper getting up to the ceiling here. And this student sort of scaled in tandem and tried to keep a scale going here where you can see the 5 packages. If I add 5 packages, I have 10. Something nifty though that the student's doing, even though it is like additive thinking, which is maybe not exactly where we want to be, but you'll notice that the student noticed that, well, wait a second, there's something going on here. If I add 5 packs and 25 centimeters, I can actually add 10 packs and I can add 50 centimeters to get here. And they're sort of noticing this pattern. Well, wait a second, if I have 20 packs is 100 centimeters, maybe I could add another 20 packs, add another 100 centimeters, and then we get closer to our height of the ceiling in packages, which is about 55 packages there. All right, I'm going to come back to this in just a moment. Now, another piece of student work that is really interesting is when students use maybe a similar model, but this model that they're using a multiplicative strategy. So when I have a look here, you'll see I have the same sort of height of my ceiling here, this bar model or almost like a double number line here. And you see though, this student started and actually went with, you know what? This is from an extension problem. That isn't what I wanted to share with you. What I wanted to share with you was a student who sort of took this model and kind of went, it looks like they took the height of the room and they kind of went sideways here with a double number line. And if I look at this work, you can see that this particular student ended up using a doubling strategy. So we're going to double our packs and our height, and then doubled again, and then doubled again, and then now went back to additive thinking, which again shows some flexibility that they won't, well, wait a second, if I've got to get from 200 to 275, that's an extra 75. It looks like this student went, well, 75 is 3 of these right here, 3 of these. So 25, 25, 25, or 5, 5, 5, which is 15 packages and 75 centimeters in order to get to the same desired outcome as our first student. That's a pretty cool one. Another one that students might be comfortable with, depending on how often that they've used ratio tables, is like taking this and then sort of like flipping it this way and thinking of it as a ratio table. Here's my packs and here's my height. And it might look something like this. And this student has a ratio table that they're using in order to get to the same place. This student said, well, wait a second. I know I've got to get to 275. So if I feel pretty good about, my tens times tables. So I'm good with that. I go, okay, well, 10 groups of 25 centimeters is 250. That's real close to where I got to get to. So I've got 50 packs, and then I can add one more group of 5 packs, which is 25 centimeters, and here we are. So if I come back to the website here, where you can actually see those strategies that we had discussed, these are all methods for scaling in tandem, where we're actually taking each equivalent ratio, like this is an equivalent ratio to this one, and this is an equivalent ratio to this one. I can scale them in tandem multiplicatively in order to get to my desired location in this relationship, which is fantastic, which is ultimately what we are doing when we set up and solve a proportion. So I think that this particular piece of work is a really good one for us to sort of see how a proportion works. And really what we did in this particular case, and if I come back over to my document camera and we have a look here, like all we've done here is we've said, you know what, I'm searching for this missing value. So I had a ratio of 5 to 25 and a ratio of x to 275. And really all I need to do, or all that's necessary, is I could set up my proportion. I could say, well, 5 to 25, or I could say 25 to 5, whichever I prefer. I prefer to put, I look at this as in a composed unit. I look at this as my dependent, like the height depends on packs. However, it's really not a hard, fast rule by any means. 25 centimeters to 5 packs is equivalent to 275 centimeters to X packs. And of course we could cross multiply here, but I guess the question becomes is like, why? Like, why are we cross multiplying? And if students aren't sure why, then that's really challenging. But in reality, you can sort of see it emerge here. Like algebraically, I can see what happens. You'll notice if I scale in tandem by 11, you'll notice that really that's the same thing as me saying, you know what? 275 centimeters is 11 times as great as 25 centimeters, and therefore this one must be 11 times as great. To me, this feels more natural. And of course, some people are saying, well, how would they know this off the hop? Well, they might not. If I'm using strategies like scaling in tandem, they can arrive there through reasoning. Something else they might do is, oh, you know what? I'm actually seeing a pattern. Like if there's a multiplicative relationship when I'm scaling in tandem, then I could actually come to this conclusion, this 11 times, the scale factor of 11, by using quotative division and saying like, well, how many groups of 25 are in 275? Like, so I could do this work to the side if I'd like. And we'll see that it's actually 11. But I would prefer to allow students to emerge this through reasoning, right? And of course, we could do this work over here as well. And then something else that I think is really interesting is at the end of the day, we can solve this algebraically, and that's essentially why cross multiplication works. Of course, you can isolate for x to be on the top and all of those things. Of course, algebraically, there's a lot of really great things that can be done here, but at the heart of it, I want a student to be able to at least solve this problem using reasoning well before we clutter things with the algebraic approach. So if like you're feeling like you have to do this algebraically, then I would argue that you want to make sure students are able to leverage these models, be it the ratio table, the double number line, or even like a bar model, sort of like our first solution that we had shared over here in our student thinking. And you'll notice that actually some other things emerge here as well. And they might not emerge the same day, like the first time that you start scaling in tandem. I would argue scaling in tandem feels very natural, but over time we can eventually reveal that there is a constant of proportionality. And in this case, I see that my height is always 5 times greater than my packages, or the number of packages is 1/5 the quantity of the height units that we have. And you can see this in this ratio table emerging. And of course, you realize that this is actually a rate, and very helpful for us when we're solving proportional relationships or working with proportional relationships, so that we can unlock this problem. Of course, again, we're sharing how this might look with a proportion. I really want to be explicit that, again, I want students to have this thinking in their mind. If a student's setting up a proportion and solving it, I want them envisioning what is happening when they solve this proportion. Either if they scale in tandem, like using their ratio reasoning skills, like this 11 times greater idea would be a scaling in tandem up and down a double number line. Or if you want to leverage the constant of proportionality, here we see that, the number of packs is 1/5 the number of measurement units or height units that we see here. It's 1/5 the size. So that means I could essentially 1/5 my 275 centimeters. That will get me my number of packs. All right. So there has to be some reasoning behind it if we're going to be setting up and solving proportions. I would say we don't want the end goal to be setting up and solving a proportion, but I'm just saying that if you feel that this is something you want students to have experience with, let's make sure that they understand how a proportion works. You can see this proportion on this number line. You could see it. And it's almost like what I envision is like when I'm doing this work over here, I'm picturing that this is equal to that. And all we've done is we've sort of taken this double number line and we've shrunk it together and we've ignored all the rest. And what I want students to be able to do is if they're looking at a proportion, I want them to be able to envision in their mind, what would this look like on a double number line or in a ratio table? And these are great tools that students can use to reason through proportional relationship and proportional reasoning problems involving ratios and rates. So this particular task is a part of It will be a 5-day unit of study, which will also have purposeful practice for you. So students begin with scaling in tandem. That's really the focus here on day 1. But then we'll work towards this rate reasoning where we reveal the constant of proportionality and get closer to looking at actual proportional relationships using an algebraic equation or by simply solving a proportion involving the constant of proportionality or the rate or the slope, as some people might know it as. So this is out there right now. Day 1 is out there on our Make Math Moments website. So if you just Google stacking paper math, that will get you there, or head on over to our Make Math Moments site, click on the tasks arrow or button, and find yourself, find the stacking paper a task for you, because not only is it super contextual, but it also has, I would say, a pretty nice finish where we actually get to see, and sort of experience what happened in the real world here using our proportional relationship skills. So I hope you found this helpful. Of course, if there's anything we can do over at Make Math Moments to help you out, please don't hesitate. Remember, the podcast is dropping every week on Mondays. Look up Making Math Moments That Matter. And of course, we're going to continue releasing our problem-based math units for teachers around the world to leverage and gobble up. So for now, my friends, I hope you have a fantastic, awesome rest of your week. And we will see you in our next video.